The James Webb Telescope has been our eye in the sky, peering into the depths of space to bring the cosmos closer to home. Its lens has unraveled the impossible, pushing the boundaries of science. During one of its movements, the James Webb Telescope revealed an image of Proxima b, our closest exoplanet neighbor. The image was captured in exquisite detail, but something unexpected happened. What could it be, and what mysteries does the James Webb Telescope still have to solve? The James Webb Space Telescope, JWST, was specifically designed to revolutionize the field of infrared astronomy. Equipped with cutting-edge high-resolution and high-sensitivity instruments, it surpasses the capabilities of its predecessor, the Hubble Space Telescope, by enabling the observation of objects previously inaccessible due to their age, distance, or faintness. This groundbreaking capability opens up a vast array of research opportunities in various areas of astronomy and cosmology. Stay to the end to find out about these discoveries and how they have affected the James Webb Telescope. Astronomers have made an incredible discovery and identified what could potentially be 6 massive galaxies from the very early stages of the universe. These objects are so incredibly large that, if confirmed, they have the potential to revolutionize our understanding of how galaxies form and evolve. These findings, published in the prestigious journal Nature, utilize data gathered by the powerful James Webb Space Telescope's infrared sensing instruments to provide a glimpse of what the universe looked like a staggering 13.5 billion years ago when it was just a mere 3% of its current age. What is truly mind-boggling is that these potential galaxies, which may have existed only 500 to 700 million years after the Big Bang, already exhibited a level of maturity comparable to that of our own 13-billion-year-old Milky Way galaxy today. The sheer mass of stars contained within each of these objects is estimated to be several billion times greater than that of our Sun, according to the research conducted. One of these galaxies could potentially have a mass of stars equivalent to a staggering 100 billion times that of our Sun. To put this into perspective, our Milky Way galaxy contains a mass of stars roughly equivalent to about 60 billion suns. This discovery serves as a stark reminder of the immense scale and complexity of the universe, offering a tantalizing glimpse into the early stages of galactic evolution and challenging our preconceived notions of how galaxies come into being. The implications of this research are profound, and what happened next after its discovery with the James Webb Telescope is something that will shock you. When Erica Nelson, an astrophysicist at the University of Colorado Boulder and a co-author of the study, expressed her surprise at the discovery of galaxies with as many stars as the Milky Way appearing so quickly, she highlighted the incredible nature of these findings. She found an exoplanet located outside of our solar system in the Centauri b star system. This exoplanet is an incredible 11 times more massive than Jupiter, the largest planet in our solar system. The Centauri b star system is classified as a young binary system, meaning that it consists of 2 stars orbiting around a common center of mass. This particular star system is located approximately 325 light-years away from Earth, making it quite a distance from our planet. Centauri b, which has recently been discovered, is one of the most massive planets ever identified. This planet orbits around 2 stars that are significantly heavier than our Sun, with a combined mass that is 6 to 10 times greater. This makes the B Centauri system the most massive one in which a planet has been observed. Additionally, Centauri b is known to be the hottest star system that hosts a planet. The 2 Centauri b stars, also known as Centauri A and Centauri b, are relatively young in cosmic terms, being only around 15 million years old. In comparison, our Sun, a G-type main sequence star, has been shining for over 4.5 billion years, making it significantly more mature. Despite their youth, the B Centauri stars have already gone through various stages of stellar evolution, shaping their characteristics and influencing their future development. The researchers were initially anticipating the discovery of small young galaxies in the early stages of the universe's development. Evo Lab, the lead researcher of the study from Swinburne University of Technology in Australia, described these galaxies as monsters that seem to have rapidly matured. The mystery of how these galaxies were able to reach such a level of maturity at such a fast pace remains unanswered, leaving scientists intrigued and eager to delve deeper into this phenomenon. They discovered Proxima Centauri near the Centauri b star. Proxima Centauri is a red dwarf star located just over 4 light-years away from Earth and is known for its frequent and intense flares of radiation. These powerful bursts of stellar energy have the potential to significantly impact the conditions on any planet orbiting the star. The radiation emitted during these flares could have a detrimental effect on the atmosphere and surface of Proxima Centauri b, potentially stripping away the protective layer of gases that allow life to thrive. The intense radiation from Proxima Centauri's flares could also pose a significant threat to any potential life forms that may exist on the planet. Exposing organisms to harmful levels of radiation could hinder their ability to survive and reproduce, making it challenging for complex life to evolve on Proxima Centauri b. Despite these challenges, the possibility of Proxima Centauri b hosting an environment conducive to life has captured the interest and excitement of scientists and astrobiologists alike. The potential for liquid water to exist on the planet, along with its location within the habitable zone of its star, makes Proxima Centauri a tantalizing target for further study. Now, using sophisticated computer models similar to those used to analyze climate change here on Earth, scientists have discovered that Proxima Centauri b can maintain vast expanses of liquid water on its surface across various scenarios. This exciting development significantly bolsters the chances of the exoplanet being able to support diverse forms of life. Despite its proximity, scientists still know very little about Proxima Centauri's planetary companion. What is known is that the planet has a mass of at least 1.3 times that of Earth and orbits its parent star every 11 days. This lack of information presents a unique challenge for researchers eager to learn more about this intriguing celestial body. This leads us to a question: is the atmosphere on Proxima Centauri b conducive to life? Proxima Centauri b, the exoplanet that orbits within its star's habitable zone, is positioned at an optimal distance from its parent star to receive sufficient starlight to maintain a surface temperature above the freezing point of water. This crucial placement within the habitable zone implies that there is potential for liquid water to exist on the planet's surface because, as we know it, water is a key factor in supporting life. However, it is noteworthy to mention that because of Proxima Centauri's orbit, which is close to its star, the planet may have become tidally locked as a result of the intense gravitational forces at play. Tidal locking means that one side of the planet always faces its star while the other remains in perpetual darkness, a phenomenon similar to the Moon's relationship with Earth where only one side is visible from our vantage point. There are two likely scenarios for the atmosphere of Proxima Centauri b. In one case, it is possible that the planet's water condensed and the hydrogen was lost to space, resulting in only oxygen or carbon dioxide remaining in the atmosphere after the planet's early history. On the other hand, it is also possible that Proxima Centauri b had a primordial hydrogen atmosphere or formed farther away from its star, which would have limited the escape of water. This suggests that Proxima Centauri b may have retained its water beyond its early history. If indeed an atmosphere exists on the planet, it is likely to contain oxygen-bearing gases such as oxygen and carbon dioxide. When combined with the star's magnetic activity, these gases could lead to the formation of auroras that might be visible from Earth and make the planet look like it has a magnetic field. Climate models, including general circulation models used to study Earth's climate, have been employed to simulate the atmospheric properties of Proxima Centauri b. These models consider various factors such as the planet's tidal locking, presence of water, carbon dioxide levels, and other variables. Scenarios for Proxima Centauri b's conditions vary widely. It could be covered in ice, feature vast oceans or smaller bodies of water, or even have dry land. Some models propose unusual features like eyeballs or lobster-shaped areas with liquid water, while others suggest a subsurface ocean beneath a thin, slushy ice layer. By leveraging these climate models, scientists explore a range of possibilities for this distant exoplanet. However, Proxima Centauri b faces significant challenges to habitability due to intense UV radiation and X-rays from its star, Proxima Centauri. The planet receives much higher levels of radiation than Earth, with cumulative X-UV radiation potentially 7 to 16 times greater. This radiation can lead to atmospheric evaporation as hydrogen escapes into space and can split water into hydrogen and oxygen, further reducing the atmosphere's ability to support life. Stellar winds and coronal mass ejections from Proxima Centauri could exacerbate atmospheric loss, potentially making the planet's environment even harsher. Despite these challenges, there is some speculation that Proxima Centauri b could retain water and atmosphere under certain conditions, possibly due to volcanic activity creating a new, carbon dioxide-rich atmosphere. Researchers are also exploring the potential for life in such extreme conditions, although this remains an open question requiring further investigation. The James Webb Space Telescope, JWST, launched in 2021, represents a major advancement in space exploration. Its larger mirror and infrared capabilities enable unprecedented observations of exoplanets and their atmospheres. Despite delays and budget increases, JWST's ability to capture detailed images and study distant celestial bodies has revolutionized our understanding of the universe, offering new insights into the cosmos and the potential for life beyond Earth.